Hello, this is how we will power the robot. Please take note that the different parts of the robot, all components, will be organized and connected to the main printed circuit board. And the printed circuit board will also serve as the chassis of the robot. And take note that there are copper traces on the circuit board that will distribute power to the different components. And in this setup, we need to power the main component, which is the microcontroller board. And that can be done by simply plugging in the USB port to another USB port, which may be coming from or connected to the computer or to a power bank. So you need to connect the robot to the computer when you upload code, and at the same time it receives power. So how much power are we talking about? We are talking about 5 volts. And basically, the robot or the system needs DC power or direct current. You can use 7 to 12 volts. 7 to 9 volts is recommended. But if you connect the robot to the computer or to a power bank, it will actually receive 5 volts through the USB port. So you have the USB port, and at the same time, power will also come out of the VIN pin. So power may go in the VIN or it may also go out of the VIN pin. So if we connect this microcontroller board to the computer, it gets power. So you have 5 volts, and let's connect VIN to a voltmeter. So VIN connects to the positive line, and ground connects to ground. So let me connect this again. So 5 volts go in, and what comes out of V in is around 3.95 volts, or more or less 4 volts. Same thing happens if you connect the microcontroller board to a power bank. So I'll use this power bank. So more or less we have the same power. So the same thing will happen here. So I'll connect this to a power bank. And 5 volts go in, and around 4 volts will go out of the V-in pin. The V-in pin is also connected to the this terminal. And if I would plug in the voltmeter here, it should get the same reading. All right, more or less same reading. So let me remove that. And in this setup, this would mean that since our motor driver is connected to V-in and ground of the microcontroller board, around 4 volts or less will be made available to the motor driver. And that amount of power or voltage will be made available to the motors. However, please take note that it is not advisable that you use the power coming from the computer to power your motors. You may also power the system by connecting 5 volts to the 5-volt pin, which is rarely done. If you do that, you will also get the a similar amount of power going out of the in. Or the standard way of powering the robot is using or by connecting a power supply through this jack, which is connected to VIN and ground over there. So from here, connects to VIN and ground, goes into the uh, microcontroller board, and whatever is the amount of power, it will be converted to 5 volts or regulated so that it will supply 5 volts to the system. So let's check. I have here 9 volts of power. So that's around 9 volts. So this is a rechargeable battery, 9 volts. This is recharged using a micro USB cable. Just connect the other end to any USB port. I have another power supply here. This is a DIY power supply. You have 2 lithium-ion batteries with a battery management system to make sure that there is no over discharge and overcharging of the batteries. So how much power are we getting from this one? We are getting 7.5. So the range of power that you will get from this battery, two batteries connected in series, should be around 7.4 to 8.4 volts. So this is a similar battery, lithium polymer, similar setup. So we're getting about the same. Also this one. This is another DIY battery, which is similar to this one. Also with a battery management system. So we are getting around 8.4 volts. This is full charge. So regardless of the amount of power or voltage, once it goes in via VIN and ground over there through this power jack, it will be reduced to 5 volts to power the entire system. However, please be reminded that if this is 8.4 volts, 8.4 volts will also be made available to the motor driver to power the motors. So if I will connect 9 volts, 9 volts will be made available to the motor driver. So again, we're talking about 9 volts. 9 volts will go into the motor, go into the microcontroller or the microcontroller board, which will be regulated or reduced to 5 volts. However, the entire 9 volts will be made available to the motor driver to power the motors. Now, if I have two connections, I have 9 volts here and I'll also connect this to the computer. So that's 9 volts plus 5 volts. How much power is now made available to the motor driver? So automatically, the system will select the higher voltage. So since 9 volts is higher than 5 volts, what is made available to the motor driver is 9 volts. So again, if you are connecting the robot to the USB port without any external power supply or a battery connected to this port or to this jack. So 5 volts go in, and the amount of power that goes into the motor driver to be used by the motors is only 4 volts or less. If we connect this, 9 volts will be made available to the motor driver instead. Take note of the light from the motor driver. So it should shine brighter when I insert 9 volts. All right. So again, I'll connect 9 volts. Take note of the light on the motor driver. So there's more power. So that is 9 volts made available to the motor driver to be used by the motors. However, please take note that the motor or the gear motor is rated 3 to 6 volts, which would mean that we should only be giving the motors around 3, minimum of 3, maximum of 6. So if we will provide below 3 volts, the motor will not turn and may also burn the motor and or motor driver. But don't worry about that. It will not happen immediately. It will take some time, but repeated procedure or repeated supply of less than 3 volts will definitely shorten the life of your motors or the motor driver. And supplying power more than 6 volts will also burn the motor or the motor driver or both. So please be aware of that. So how are we going to go about that? So in this case, we can actually regulate the amount of power that goes into the motor by only utilizing a percentage of the total amount of power. So in this case, if we are going to use 9 volts, the amount of power, the minimum amount of power that we should utilize is 33%, which is 3 volts. And maximum is 66% or 6 volts. How did we get that? Simply use a calculator. So minimum is 3 volts. So 3 over 9 volts, the total voltage. So that should result to 0.33 or 33%. Since 6 volts is the maximum, so 6 over 9 volts, that should be 0.66 or 66%. And if we are not going to use any battery, so no battery at all, no external power supply, and we will only utilize the USB port, we have to take note that the total amount of voltage available will be around 3.8 volts, a little bit less than 4 volts. So we have 3 over 3.8, the minimum amount of power that we should get or utilize to get the motor moving should be around 78% of 3.8 volts. And even if we use 100% of whatever power is available using the USB port, we can only get 3.8 volts. And if we're going to use 12 volts, so 3 over 12, we should only utilize 25% and maximum of 50%. So 6 over 12 is 50%. And where do we get that power? We can actually get that power from an AC to DC power supply. So here it is. You have 12 volts of power. So we have to be very careful when using 12 volts because using 12 volts to power the motor, so that is beyond 6 volts, it might or it will definitely burn the motor and the motor driver. And if we have 5 volts, assuming we have 5 volts, and that can be done by changing the power cord or the plug of the USB port from the power bank, the microcontroller board, with this one. So this is from USB to DC barrel jack. So if I'll connect this, so remember this is 5 volts coming from a USB port, and connect this to the robot via this port. The microcontroller will also get 5 volts. And if that is the case, take note of the computation. So you have 3 over 5. So that should be 60% only of the total amount of power that is available, which is 5 volts in this case. And even if you use 100%, it will only be 5 volts because that's the only available coming from a USB port, in this case from a power bank. So let's check that with the robot. So I'm not going to connect anything yet. And let's use this sample code. And in this code, we have the usual connection. And we have here the setup. All pins are set for output. And here, I'm going to send power or tell the motor driver to send or allow power equivalent to 100%. But if I'll be using 9 volts, that will be too much. What I'll do is I'll regulate by changing the values from 255 to, let's check first. In this case, I should use at least 33% to make it turn. So I'll use around 40. So 40, how do I get the correct amount? So 0 is 0 and 255 is 100%. So 255 has something to do with the binary number or binary number system, which means that in 1 byte, the computer can actually represent numbers 0 to 255. So we'll stick to that. So again, 0 is 0%, 255 is 100. And if we're going to utilize 40% of 9 volts, let's compute. So 40%. So 9 volts times zero point 0.4, that would be around 3.6 volts, which is enough for the wheels to turn, which is more than enough for the wheels to turn. And what is 40% of 255? So 255 times zero point 0.4, so that is 102. So 102. Let's do the same with the right motor. And I'm going to plug it in at the same time, connect or connect it to the computer. Let me upload. So one more time, let's check the code. So it should send 40% power to the motors based on the 9-volt battery. So that's around 3.6 volts and should run for 2 seconds and should stop afterwards. So I'll be sending 0 to all pins connected to the motors. And this will be an infinite loop. So this will be a forever pause. And the loop function should not repeat. Okay, let's check. Let me upload. And so that's good for 2 seconds. And that is 40% of 9 volts. And maximum should be around 6% or 6 volts. So if we change that, so that would be 255 times 0.6, that's 153. Let's change it. 153. 153. Let's upload. So it should be running faster this time. Okay, let's put it back to 40%. So it's 102. So that's 3.6 volts. Upload, and it should run a little bit slower. Okay. Now, if we are going to remove the power coming from the motor, from the 9-volt battery, this would mean that we are going to make use of around 3.8 volts, since 5 volts go into the microcontroller board, and around 3.8 volts, less than 4 volts, is available to the motors or to the motor driver instead of 9 volts. So if we will stick with this one, and this is 40%, and remember that 40% of 3.8 volts is actually, so let's check, 3.8 volts times 40% is 1.52, which is around just 1.5 volts, which should not be because the motors are rated 3 volts. So around 3 volts should be supplied for the motor to turn. So if that is the case, and we'll continue with the current code, what will happen is the motors will not turn, or it might need help for it to turn or start turning. So I'll upload again. So it needed help because 1.5 volts is not enough to make the motor start. So again, I'll upload. We won't be giving any help and the motors will not turn, and that's the end, which would mean that uh, if you continue doing that, you are going to shorten the life of your motor and the motor driver. So if that is the case, you have to make changes to your code if you are not going to use a battery or stick to the USB power coming from a power bank. So let's check. The minimum amount of power is 78%. So what is 78% of 3.8 volts? So 3.8 volts times, let's make it 80. 80%. So we're talking about 3 volts. And 80% of 255 is 204. So let's change this to 204. Upload. Check the motors. It should now turn. So uploading. Which is not the case. So which means that we have to add more. So let's try 90%. So what is 90%? So that's around 230. 230. Let's do that again. Okay, there you go. That is why the USB power supply is not really recommended in powering your motors. But let's check. Now let's put it back to what it was, 204, and let's use a power bank instead. But let me upload it first. So this is 80%. The computer is not enough to power the motors. So let's remove the computer and let's use the power bank to power the motor driver or to power the microcontroller board, because I'll use this instead. So this goes in to the microcontroller board and goes out for the motor driver by the VIN pin as 3.8 volts. Is it enough? And in this case, it is not enough. So, however, if we're going to make changes, instead of 3.8 volts or 12 volts. Just make the entire 5 volts available to the motor driver by changing the cable with this one. Because what is 80% of 5 volts? So that would be 80% 5 volts times 0.8 is 4 volts, which is more than enough to make the motor turn. All right. However, please take note that 204, if you are going to make a mistake and plug in the 9 volts back to the port, and 80% of 9 volts is actually, let's check, 9 times 0.8 is around 7.2. So let's do that. Hold on. So let's try again. Okay. So that's 7.2 volts. And the reason why I had to put a delay here and stop all the motors is just in case that I make a mistake, the motors will actually not burn since it will only run for 2 seconds. And also, if you are going to use the motor functions that were discussed or featured in the previous activities, you would find that it's easier to use forward, reverse, left, and right instead. So here, instead of doing it manually, I'll just change this to forward. Forward for 60% or 40%. If I'm talking about the 9-volt battery, but let me plug this in first. There you go. So, which is a lot easier. So that's 40%. But remember, the functions should be present in your code. So these are the functions that were discussed in the different activities. And all of them should be present here. So forward for 40% and delay for 2 seconds and then stop. Of course, instead of doing this, I can just say stop. So that's a lot easier. So let's check. %, and again, without the 9-volt battery, I will only use the USB power supply or the USB power, which is 5 volts that goes in and less than 4 volts that goes out for the motor driver. So I'll use 90% power. I'll upload. And that's it. So you have to be very careful in setting the power since you might end up burning the motor and or the motor driver. So again, so that is the summary. And those are the sample values. You already saw how we computed for those values if you're going to use analog, right? But since we already have the functions available for us to use, we can just opt for the forward function, forward, reverse, left, or right. Again, assuming that you have written the functions here. So that is based on the earlier activities on how to control DC motors. And uh, so in this setup, take note that both the microcontroller and motor driver use the same power supply. No? So they are being shared by both the microcontroller and the motor driver, which may result to malfunction later on due to inconsistent or low voltage after some time. So you have to take note of the maximum operating time of the power source. In this case, this should be enough for around 30 minutes to 1 hour, depending on the use. But since this is a training robot, there's really no need for you to need that amount of or an extra amount of power. But should you need more power, just replace the battery with something that has more capacity, or you can opt for this one, which will provide you unlimited power but with limited mobility. But again, please take note that this is 12 volts and your motor is only rated 3 to 6 volts. Also, a separate power supply may be provided for the motor driver. So separate power supply for the microcontroller and the motor driver, but that will be a different topic. And that's all for now. Again, be very careful in setting the power or in writing the code and in supplying power to the motors. Thank you and have a nice day.